fishing. Okay. So, we're going over science. Did I hear a yay? That would warm my heart. I'm a fan of science. I'm a fan of the philosophy of science as well. So here are some questions that we will be asking. We discussed these questions yesterday. Do you guys have questions about what we talked about yesterday? Or maybe questions about these particular questions up here that are circled? Okie doke. So today we're going to be focusing in on this question. What do we learn from failed hypotheses? Some people call this falsification, right? So when we have a prediction and the prediction is not borne out, we think we've falsified whatever hypothesis is associated with that prediction. So that's what we're talking about. And I think yesterday we reviewed the logic of falsification. So I gave you this problem. Your phone or computer is not getting Wi-Fi, but it is accepting your Wi-Fi password. So the problem is not your password. So you come up with some hypotheses. Here's the main hypothesis we'll consider. If the problem is that the router lost connection to the internet, then rebooting the router will fix it. You might have other hypotheses, but we're going to focus on that first one. So then you run a test, you reboot the router, and observe that it did not fix your problem. So the problem is not that the router lost connection to the internet, yeah? So in the reading, Ph.D. casts doubt on our ability to draw this conclusion. Maybe you kind of also had some of the same thoughts that Duham had before you even read it. Why would we not be able to falsify? Or why would we, why can we not draw that conclusion? Or why can we not falsify hypothesis 1? I think some of you had this idea yesterday. Yes?
You mentioned something about there being too many variables and you not being able to trace it back directly to a single entity being a reason.
Good. So many variables. So we have this hypothesis. And this hypothesis, something about what Taylor is saying is, this hypothesis involves more than one thing. Like, what else might it involve? Yeah. Good. So something that's not stated, you could consider them hidden premises. In the reading, they're called just, other hypotheses, and sometimes they're also called theories. So we can also call them auxiliary assumptions. That's a word we're going to use later on in a reading from Carol Cleland. But the idea is that the antecedent, meaning the if part of that if-then clause, there's more than one thing in the if part of that if-then clause. What other things are there? There are these other hypotheses, these other theoretical claims, or these auxiliary assumptions. Here are some. H1 is assuming that your phone is not in airplane mode, or your computer is not in airplane mode. That you're within the router's range, that there's an internet cable plugged into your router, that that internet cable works, and that there's data flowing through that internet cable. So if you've ever been on like the phone with, technical support, right? They want to ask you all sorts of questions when you're like, hey, my Wi-Fi's not working, or something's not working. They start asking you questions. Why might they ask you questions? Because they're testing hypotheses. And, to the layperson, you might think, why isn't my phone connecting to the Wi-Fi? Something about the router. But, the person on the other end of the phone realizes, no, there's many other variables at stake here. So that's why I need to ask you specific questions like, can you tell me if your phone is in airplane mode or not? Or, and just so we're on the same page, there is a cable connected to your router, right? And then they'll ask you to try a different cable, right? Because they want to see if the problem was just the cable. And then if you're talking with Comcast, they'll ping your router to see if, Comcast can even see your router on their network, which is testing the idea that there's actually data flowing through that cable. So again, the person on the other end is aware of this entire problem. The fact that whatever your hypothesis is about your Wi-Fi, there are many assumptions built into that hypothesis, and they're going to try to test them. So really, hypothesis 1 looks something like this. If the problem is that the router lost connection to the internet, and your phone is not in airplane mode, and you are within range of the router, and an internet cable is plugged into your router, etc., 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 then rebooting the router will fix it. Rebooting the router did not fix it. So which hypothesis did we falsify of the things on that list? One of them, some of them, all of them? James?
One or more.
One or more. That's a pretty conservative answer. I like that. We falsified something. Good. Good. Anyone want to offer a different answer or disagree with the answer that James is floating? Yeah, go ahead.
Just the first, if the problem is that the router lost connection to the internet, everything else you're not sure of.
So you do think that we did falsify that first clause if the problem is that the router lost connection.
Yeah.
So you do think we can conclude the router did not lose connection.
Yeah.
Okay. And why do you think that?
Because the only thing that is proven by rebooting the router is the connection to the internet. Everything else you're still not sure of because it doesn't. Oh, wait. So all those bullet points are saying that's already happening.
We don't know.
Oh.
So that's a part of the hypothesis. Yeah. So this is helpful. So the hypothesis is there's the if and then there's the then. All of the bullet points are on the if.
Oh. Okay.
So it's if this and then if the other bullet point and then if the other bullet point and then if the other bullet point. Then, and we've made one observation, and the observation is we rebooted the router and the problem did not go away. So we did not make observations about the phone being in airplane mode, us being in range of the router, etc., etc. We've made observations only about rebooting and what happened.
So that's just assuming that if those are all right, then
That's what the original hypothesis would need to assume is something like a long list of things like this. There's probably many more. It would be assuming, but the idea is you can very quickly realize that any given hypothesis is probably assuming a lot.
Yeah. Okay. Right. Sorry, I misunderstood the first one.
I think it's understandable. There were other hands. Does anyone go ahead?
Because you only observed the router not working, wouldn't that falsify the premise that the router was a problem? Since you haven't observed they're just hypotheses.
Okay, so
Observations.
So your thought is, we've got a list of things on the if part of this if-then clause. One of them is this thing about the router. Our observation was about this router thing, but not these other things. So if we falsified anything, we've falsified the router part, but not the other things. Okay, so now let's say we check your phone and it's in airplane mode. Should we still say that prior to checking your phone, we did falsify that first part of the hypothesis? Seems like we maybe want to say, I guess we didn't falsify that part of the hypothesis. Go ahead.
It wasn't airplane mode, then it'd be fixed, right? Because you said it says if your phone is not in airplane mode.
Okay, so the bullet points are not observations. The bullet points are, I guess we should add if in front of every one of those. So if the problem is that the router lost connection to the internet, and if your phone is not in airplane mode, and if you are within range of the router, et cetera, et cetera. So if all of those ifs are the case, then rebooting the router won't fix it. We reboot the router, doesn't fix it. Can we falsify
So then we falsify every.
all of them?
Yeah.
Okay, so far our answers are one or more, just the first one, although we might want to take that one back, depending on the details. And now we've got another answer on the table, which is all of them. Okay, other answers. I saw other hands at some point, so you're welcome to weigh in if you're still having thoughts. So Duham argues we don't know. We have no idea which one we falsified. So this view gets called holism. You might call it epistemological holism. Because we're not going over more than one type of holism, we can just call it holism. So here's an argument for holism. All scientific predictions involve multiple hypotheses, namely like all the stuff we're listing with the bullets here. If observation does not indicate which hypothesis is falsified by a failed prediction, then we cannot falsify just one hypothesis. Observation does not indicate which hypothesis is falsified by a failed prediction. So what's the conclusion? I'll let you guys finish writing it down. Oh, yeah, go ahead.
Are you asking anything?
Yeah, I'm asking.
Would it just be that we cannot falsify just one hypothesis?
Excellent. And the idea that we can't falsify just one of a set of hypotheses, that's the epistemic holism idea. So how can you remember holism? The idea is like, look, all of the hypotheses or claims or whatever, they hang together. You can't just like pick one out without affecting the rest of them. They're a whole. So how might you criticize this argument? You guys know how arguments are supposed to work. So how might this one not work? Somebody give me a rule for good arguments. Go ahead.
All premises must be true or plausible.
Okay, so that's one of the things we want to know about this argument. Are all the premises true or plausible? Okay, what's another rule? Go ahead.
The premises must support the conclusion.
Good. So the other question we would want to ask if we're considering just the argument is, do these premises support the conclusion? You know, there are other ways of asking that question. You know, if the premises are true, would that mean that the conclusion must be true? That's another way to talk about this support. Do the premises guarantee the conclusion? Cool. So the true plausible stuff, are the premises true or plausible? Or the support bit? Do the premises make the conclusion true? Do we have both of those here? You can argue yes or no. Let me try to prime your intuitions a bit. If this argument is correct, like if that conclusion is true, what does that tell us about science? Did we falsify Newtonian physics? Or not? Go ahead.
In regards to like that thought, we came up with more information, but the information didn't lead to a single conclusion. But also, as far as these being true or plausible, I feel like yes, but they're like kind of like ifs. They're not saying like whether it's kind of true or not. They're saying like if this is this, then yada yada yada. But I don't know if that's still the same.
Okay, so there's two thoughts that Taylor's bringing up. One is something like, in the case of Newtonian physics or others like it, where these like big revolutionary moments in science where we have this like big theory, and then we say, I think that theory's wrong, or that hypothesis is wrong, whatever we call it. It's probably not the case that we're picking out one like particular thing about the world and saying that particular thing is wrong. So maybe, if you look at the history of science, you actually do find that something like this is true. When we falsify things, we falsify like big groups of hypotheses or claims. Because like Newtonian physics, right, like is not a claim, it's a bunch of them. And we falsified the whole group, maybe? We falsified one or more parts of that. So maybe Doom could still be correct. Then the other part of what Taylor is mentioning is this idea that like this plausible thing, that's a funny word, right? I get what it would mean if all the premises are true. That makes sense. True, false, it's binary, right? It's one or the other, it's black and white. But plausible, how do I answer the question of, is a premise plausible, yes or no? And if a premise is plausible, what follows? And the idea is like something could be plausible but not true, maybe? So like plausible's less than true? And if plausible's less than true, does that mean the conclusion would be less than true or something like that? And so, if I'm understanding you correctly, the idea was like, look, I get this is a good argument, but maybe the conclusion, all it gets us is the idea that the conclusion is plausible, but not like, you know, full-blown true. So we don't have to be like super concerned about what this could mean for science, because it's merely plausible. Is that a fair?
Yeah.
Okay. Any other thoughts for or against the argument or its conclusion? So in the in-class assignment today, you're going to end up testing some hypotheses. And at the very end of the in-class assignment, you're supposed to decide whether or not you have just demonstrated that doing is wrong. You're going to test a bunch of different hypotheses and come to some sort of conclusion after multiple testing instances. So maybe we can see how that demonstration goes when we get there. For now, questions about the course material, and by that I mean today's stuff and I guess yesterday's stuff. Alternatively, questions about the course, like housekeeping stuff, like stuff that's on the syllabus.
Tomorrow we have review day.
We do.
So,
We're going to talk about that a bit more in a second. So the review. Here's what I recommend you do. Finish all your team-based assignments. If you've finished them, review them. And bring them to class, in case this wasn't obvious. And then here's what you should be trying to do in class, in case this wasn't obvious. So you probably can't just say, hey, what's the answer to this one? Otherwise, your notes are not notes about what you understand. They're just notes about whatever I said on Wednesday of a particular week. Right? So it still needs to be the case that you actually understand the material. So you'll have to come up with a better question than what's the answer. So here's a suggestion for how to do that. Think of specific questions that are about, like a whole category of questions that I could ask, right? Here's an example. There's a particular question on one of your in-class assignments that you think maybe you have the right answer, but you're not sure. So you say, I thought something like this for this particular reason. However, I'm unsure about this thing. What are some strategies for answering questions like this? And then I can help you think about strategies about how to solve those. That way, you're not getting an answer to like one particular question out of hundreds. You're getting, strategies that will help you solve a whole family of questions. Because there's just not time to go over like every single item tomorrow, right? Like even if you did say, hey, what's the answer to every single one tomorrow? We just wouldn't finish in 90 minutes. So the strategy here is to make sure you have the tools to answer entire families of questions, so that we can give you strategies that will probably give you all the strategies you need for all of the material. Cool. So that's the review. Questions about the review? I am not, in case this wasn't clear, I'm not you no longer have to read whatever was on the syllabus for tomorrow's reading. It was like the Karl Popper reading. I think it's called The Problem of Induction. So you don't have to read that. Okay, on to today's in-class assignment.